Okay, Assalamualaikum and salam sejahtera. Today, I'm going to present a paper entitled Incorporating History of Electricity and Magnetism into Activities for Non-Engineering Students. My name is Mr. Muhammad ZAKI bin DAUD. I'm from School of Electrical Engineering, Faculty of Engineering, University Technology, Malaysia. This paper is produced by me, Muhammad ZAKI DAUD, and Associate Professor Dr. Shahrin MD Ayub. First, I'm going to talk about the introduction, the background, and also the paper to support the activities. So we see that the extensive technical difficulties dealing with mathematical contents of electrical technology course may allow non-electrical engineering students lose interest in the course. If history of electricity and magnetism is incorporated into activities for group assignment, this may motivate them and give them an opportunity to explore the course from non-technical perspective, which is the objective of this paper. So the first paper that support my research is in terms of integrating history into engineering curriculum, which was done by this paper looking into integrating history into civil engineering. And the second one is a paper entitled Does Interdisciplinarity Promote Learning? Theoretical Support and Researchable Questions. So in this paper, it has been shown that the interdisciplinary approach of integrating elements of history into technical engineering courses has potential to result in improved student learning and engagement. So what is my application design? The course that involved in this study is SKAU 3053 Electrical Technology. It is 16 students involved in UTM Space student, which is centered in Kuala Lumpur. And I'm using documentaries for them to watch. And each group, they will be divided into 3 groups. They are required to produce either a mind map, devise a simple demo kit, or write a reflection notes. They can either produce one of these or all of them. Okay, the overview regarding the Bachelor of Technology with Education, Electric and Electronic. The program is under School of Education, Faculty of Social Sciences and Humanities, University Technology, Malaysia. And the program outcomes for the is knowledge and applications of electric and electronic. They need to demonstrate knowledge of the principles of electric and electronic and the teaching and learning methods. We have the lectures, tutorials, seminars, problem-based learning, and also student activities. Okay, the assessment in terms of examination, tests, quizzes, and also group activities. So basically, they need to watch 3 episodes, each around 60 minutes length. The first episode is about Spark, how pioneers unlocked the electricity mysteries and built strange instruments to create it. The second episode is about the age of invention, how harnessing the link between magnetism and electricity transformed the world. And the third episode, revelations and revolutions. After centuries of experimentation, how we finally come to understand electromagnetism. So the findings and the discussions encompass the 3 learning domains, which is the cognitive, psychomotor, and also the reflection notes. The video is subtitled in English, so that the students can understand better the content of the video, and from there they can write or they can produce a mind map and get an idea how to devise a demo kit or also write a reflection notes. So I show you the sample of the video that they need to watch.
But the biggest surprise for Volta was that the electricity it generated was continuous. In fact, it poured out like water in a stream. And just as in a stream where the measure of the amount of water flowing is called a current, so the electricity flowing out of the pile became known as an electrical current. "200 years after Volta, we finally understand what electricity actually is."
So we want to see the findings. First, there are 3 groups involved: the group Tesla, the group Faraday, and also the group Ampere. So one group consists of 5 students, the other group consists of 5 students, and one more group consists of 6 students. All in all, there are 16 students involved in these activities. So what they do in this Tesla group is that they produce a mind map using online collaborative tool, which is Jamboard, Google Jamboard. So each student, like in this group, there are 5 students involved, and each of them watch around 12 minutes for a certain episode. In this case, they are watching episode 3. So each student produce each portion of the video. And the Faraday group, what they do is that they're watching the first episode, and each student also watch around 12 minutes length, because we don't want to burden for them to watch the total part, and they combine the mind map in these regards. And another group, the Ampere group, also produce a mind map in terms of, it's not a mind map, but it's a lot more like notes. And each depends on their understanding and how their creativity to produce what is needed. For the demo kit, what they are producing is really impressive. Okay, they make full use of the Faraday's law of electromagnetic induction. Okay, they want to show how the changes of magnetic field will produce a induced EMF, and if you have a complete circuit, they will lighten this bulb, right? So this is what they have done. Okay, so they put here the explanation of the theory and how the bulb be able to light up even though they are not connecting to power. So the third is regarding the reflection. Okay, one group watched the episode number 3 and they produce this reflection in terms of the scientists. Okay, before this, there are certain scientists, they are not familiar, and after watching the video, they are familiar what are the contributions of those scientists such as Faraday, Edison, and Tesla, right? And they can have a better understanding how those technology evolve, right? And they also give a suggestion by the suitability of the video to be introduced to the school children and the prime university students. So with this feedback, they already contribute to the studies. Okay, in conclusion, the approach of incorporating elements of history into students' activities has resulted in improved student learning and engagement. All right, so they look at the course in a more lighter way, non-technical aspect, no mathematical equations, which is a good sign. All right, and we also, the 3 learning domains, cognitive, psychomotor, and affective, has also been explored and applied in the students' activities, from incorporating history of electricity and magnetism into students' activities. Students have utilized different collaborative platforms to produce mind map, design a working demonstration kit to illustrate the application of electromagnetism, and being able to include affective aspect in the reflection notes after watching the documentaries. Right? These findings may help to using the same application design for students from electrical engineering background and also to the newly admitted students for their first year activities. Okay. Thank you very much from me.